Come back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share anywhere you see our video, and also subscribe if you have not subscribed before. Help us to press on subscribe button for you to get direct updates and also get everything. Now, also to reach us, you can reach us with this number. Reach us with this number. You are allowed to call. You can call us. You can also WhatsApp us, and also Telegram is allowed. Okay. In this video, I'll be working. That should be the last part of that circular motion, which is energy of simple harmonic motion. Okay. Which is, it should be video 4 on it. Now, when we talk about energy of a simple harmonic motion, we all know what energy is always is ability or capacity to do work. Now, when we talk about energy of simple harmonic motion, it means the energy of is simple harmonic motion. The energy of simple harmonic motion is derived when the motion of a load or loaded see that. Now, that is what energy of simple harmonic motion is all about. And also there are a lot of equations that you can also relate with here. The first one, you can say that my T equals to 2 pi root of and there's no way we talk about the energy of simple harmonic motion that we won't talk about potential energy and kinetic energy. Is very important. Put that at the back of your mind. And let me try to, or we have this as T squared equals to 4 pi squared m all over k. And also we can say that my frequency equals to kinetic energy, or which is ke, or I have it as mg, which is my force. My force equals to this ke, which is my equals to ke, anyhow you want to do it. And also let me put this as 2. My 3, I can have this as 2 pi root of e all over g, or we have it as t squared all over 4 pi squared e all over g. And on the 4, we have it as equals to root of k all divided by n, which I have it 5. I can also have my frequency, my force, my frequency equals to 1 all over 2 pi root of k all over m, or you have it another way, squared of k all over 4 pi squared m, anyhow you want to do it. Okay. And 6, you can have this as my angular velocity, which is 1 all over 2k ampere squared, and amplitude squared, which also we have it as 2m and of a squared, anyhow you want to. They're the same thing, which is my weight. This is my weight. This can be my weight. And don't forget that my T is where T is period. We have been on that things, which is always in seconds. My M is also known as mass, which is always in kilogram. My E is called extension, which is always extension of the spring, which is always in meter. What again? My G is acceleration due to gravity. Should have been on that. Acceleration due to gravity. And what again is there? We are also, my F is force. My F is force or load, or we call it tension. Anyhow, we call it tension. Okay, and what again? This is, and we have what is here again. We have this is called angular velocity, and which is always in this one is Newton. Why this one is meter per rad per seconds. Rad per seconds. Take note of that. And what again? We have my small letter F. We call it frequency. Frequency, which is always equals to or inverse of seconds. What again that is there? Okay, we have our W is known as W is known as total work done. Total work done. Total work done of this by the spring. Spring, which is always we know, or energy, wherever which is always in joule, or the energy. What again we need to talk about them? I think I've talked about everything. Okay, my A, I have A. We call A amplitude. Amplitude, which is always in meter. What again that is there? Okay, these are the things that we need to understand as far as energy of simple harmonic motion is concerned. Let me try to explain apply one or two if time permits me. Just give me time. Okay, a body of mass 500 grams suspended from the end of a spiral spring, which obey Hooke's law. We have done Hooke's law, which is Hooke's law. Okay, provided and extension of 10 centimeter if the mass is pulled down a distance of 5 centimeter and released and released. Calculate one, the force constant of the spring. 2, the frequency of oscillation. 3, the period of oscillation. 4, the angular speed of the body. Solution to this problem. When I have this type of question, the first thing I will ask myself is, what are the things available for me to play around with? The first thing, I have my mass. The second thing, we are talking about Hooke's law. Hooke's law let us to know that from Hooke's law, we say that my force is directly proportional to what? E. Now, this is always constant. We all know that. Which my constant K can also be equals to all over E. Which I can say mj all over E. And all these are available. Don't forget that my mass, which is my m, is 500 gram, which I cannot use 500 gram. I will convert it to what? Kilogram, which it will be equals to 0.5 kilogram by conversion. 1000 gram make 1 kilogram. By so that I will have it. Now my E, which is my extension, is what is my E? Okay, extension of 10, which is 10 centimeter. I will convert this also, which is 0.1, because we all know that 100 centimeter make 1 meter, right? So that I will have this. Since I have this, I can now continue by having, with my first question, I can now continue from the force K. I think I can say that which I have 0.5, which I'm talking about my K, constant K, because we're talking about constant of the spring. It means the force constant of the what? Of the spring. It means I'll be having mj all over E. We all know that my m is what? My m is always 0.5 multiplied by 10 meter per second squared divided by, what is my E? 10, which is cancel. It means I'll be talking about 0.5. The answer is 0.5 Newton per meter. That is number 1. Number 2, I'll continue also by having, how do I do number 2? I know that my number 2, we are talking about the frequency of oscillation. The frequency of oscillation is always like I'm talking about my F frequency, which is 1 all over 2 pi of root of K all over. That is what we need by frequency, because we all know that what is my 2 pi? We have them, or we have 2 pi already, which I have it as okay, which I have that. Now with this, I can continue by having it because of we have 50 as my K. My K is 50. Okay. Okay, pulled to the center. Okay, a body of this is okay. And base Hooke's law provided an insertion of this. If the mass of this go down to the, this is 50. Centimeter. This is 5 centimeter. Now, which I'll convert 5 centimeter I will convert 5 centimeters, which is my mass. My mass is something x. Now with this, I think I can get my frequency anyway. With this, I can get my frequency, which I will be talking about. My frequency will be talking about. Which I'll be having my frequency equals to 1/2 pi root of 50 divided by is it 50? 50 divided by is 0.5, which yes, that'll be, I'm talking about frequency equals to 1/2 pi root of 50 multiplied by 2, which is 100. Root of 100 is always equals to 1/pi of 50. 1/pi of 50. Yes. Oh, this is 10 rather. This is 10. Root of 100 is 10, which is 5. I'll be having 5/pi, which is, what is my pi? I can press my calculator and what's my pi? 5/3.2, which I have my answer. That is my frequency, and frequency is always inverse of seconds. Don't forget that. And I can move on to my period, which is number 3. My period is always equals to 1/frequency, which I can say that the story will now change to be 3, 4, all divided by 5, which is, that is what I'll be having. And the next one, I'm talking about angular speed of the body. Angular speed of the body, which is, I can say that number 4, my angular speed, it will be equals to root of k all over mass. I showed you that I can have it as 50 divided by 0.5, which I will be having root also, which is root of 100, which it will be 10. That will be 10 rad per seconds. That is all about 10 rad per seconds. That's all about that. Oh, I've not completed this. Please make sure you press the calculator. This one will give us period with seconds, and inverse of seconds is frequency. Don't forget that. Okay, I'll be stopping here for now. Don't forget you are on with Further Solutions Academy. Encourage us more to share to your friends, and encourage us more to share Further Solutions Academy. Encourage us more to share and also subscribe. Share and subscribe. Thanks for watching.